Section 12.5, recursive rules, second part. Now we have to go in the harder direction where we have to write the rule. So write a recursive rule for the sequence. And the sequence, we actually don't know if the sequence, it might be, if we can see that it's arithmetic or geometric, they're actually very easy to do, if we can identify that pattern. And if it's not, then you have to be a little more creative. And we'll do some examples. So number one, we're just going to go right into it. 4 or 5 examples. So let's say I have 2, 14, 98, 686. What is happening? And now we get to look at, in terms of the previous term, what's happening, because we want to write a recursive rule. So this is, in some sense, it's easier. So what's going on there? What kind of sequence is that? It is geometric. Nice. And so I'm going to write geometric. And what is the common ratio? Excellent. So let's just try to write the answer then. That would be enough work to show. So the way you write a recursive rule for this, you would say a sub 1 equals 2. You have to identify the first term by saying a sub 1. And then you would say the nth term, a sub n, equals 7 times the previous term. And how do we notate previous term? Yes, a sub n minus 1. That is the answer. Done. So that's if it's geometric, that's how you would, and you can always, like on a quick quiz, you can take your answer and work backward and plug in 1, 2, 3 and make sure you get these sequence terms. Okay, let's try a different one. 19, 13, 7, 1, negative 5, ... What is happening there? Very good. It's arithmetic, so I'll write arithmetic. And what is the common difference? Ooh, it's not 6, it's negative 6, because it's going down. So, our rule is a sub 1 equals what? 19, and a sub n equals what? Yeah, John?
A sub n minus 1 plus negative 6.
Yes, perfect. And he said plus negative 6, which you could write, or you could say just minus 6. Either one is perfectly fine. Okay, so that's how it's going to go if it's arithmetic or geometric. Any questions on that? Let's do, I want to do one more. You try, and you won't know which one it is. One more of that type, and then we'll change it up. 324, 108, 36, 12, 4, ... Okay, so I'll just give you a minute. You just write the answer, write what it is, write the answer on your paper. So 324, 108, 36, 12, and 4. What is happening? What is the pattern? And then what's the recursive rule for that? And then we'll do 2 that are neither arithmetic or geometric. And we have to work a little bit harder. But this would be, this is one or the other. So, someone want to try? Yeah, just. Okay, so a sub n minus 1 divided by 3, or, so I think what you're saying is a sub n equals, you could write it like this, 1/3 a sub n minus 1. That's how you would, so you have to write it like that. You can't just say a sub n minus 1 over 3, because you have to write it in terms of the previous term. But you totally got the pattern. That's exactly right. So you also have to state, for this definition, if I just wrote that, I wouldn't even know where to start. If someone just blindly gave you that, you would not be able to expand that, because you don't even know what the previous term is. Do you see that? So you have to Otherwise it breaks the link. In computer science, when you start a loop, you have to say where you're going to start, which is usually 1 or 0. Okay, so you have to give that, you have to know to define it, to give what the starting is, since you're defining it in terms of the previous. And indeed, this is geometric, just to fill in the blanks, and the common ratio was 1/3, which you could get by taking any term and dividing by the previous term. If you weren't sure, just do the division. 12 divided by 36 is 1/3. Now let's try the most interesting ones. Let's look at this beautiful sequence right here. This famous one, and I might show a little fun video on this too if we have time. This is a famous little sequence there. 1, 1, 2, 3, 5. I'll even put one more in. 8. I'll keep going. One more. 13. What is happening? So you kind of have to, it's helpful to write in words what's happening on these. So what is happening? It's like a little code. 1, 1, 2, 3, 5, 8, 13. Famous sequence. It is not arithmetic or geometric. John, what's happening?
Well, like, I don't really know how you get the first number, but if you take the first two numbers and plus them together, then that's 2. And then you go 2 and 1 equals 3, and 3 and 2, 5. 5 and 3, 8, 8 and 5, 13.
Beautiful. Perfect. Each term, what he's saying is each term is the sum of previous 2 terms. And I love that John also said that he doesn't know where the first term comes from, and I don't either. And you have to give that. So when you define the rule for this is how it works. You have to give both. A sub 1 equals 1, and you have to say what the second term is. You have to give them both, because the next term, in general, a sub n equals a sub n minus 2 plus a sub n minus 1. Let me back up for a second. So this is your final answer. You have to say, so first notice that if you add any 2 terms, that gives you the one after it. That's what's so great about it. 1 plus 2 is 3, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 5 is 13. That's what's happening. So you state what the first 2 terms are, and then this is notation for any n term is the sum of the 1, 2 before it and the 1, 1 before it, or the previous 2 plus the previous 1. So we're going to do any questions on that one? That's called, do you know the name for it? Fibonacci series. And it follows, like patterns in nature follow this sequence, and I'll show you a video on that. 5 is, last one is, let's try this. 1, 2, 2, 4, 8, 32. So you look at it and you kind of do a guess and check. You're trying to crack the code, what's going on there. Someone, yeah, Kylan? Perfect. Someone's got a knack for this. Each term is so let me just write it this way. Multiply previous 2 terms to get your term. And remember, the difference between this and the explicit ones that we've been doing up until now is you get to use the previous terms to get to where you are. That's the whole idea of recursion. It makes it actually easier to think about this way, and you can tell the computer understands how to unravel things when you define it recursively. Multiply previous 2 terms, so a sub 1 equals 1. You have to state what a sub 1 is. You have to state what a sub 2 is, because we have to use both of those. And so the nth term, this is how you would write it. You would just say a sub n minus 2 times a sub n minus 1. And so for your homework tonight, you're going to make up some pattern, it's more fun if it's not arithmetic or geometric. But it's up to you. You're going to make up your own, and then you'll define it recursively, like that. And you'll know what the pattern is because you made it up. So make it cool. All right.